Welcome to today's Explainer. We've got a fantastic lesson lined up for you. We're diving straight into the physics of rainbows. We'll explore exactly how ordinary, everyday sunlight transforms into that giant, breathtaking arc of brilliant colors across the sky. If you've ever looked up after a storm and just wondered about the science behind that incredible sight, well, you're in the right place.
So, let me kick things off with a quick question. Can you ever actually touch a rainbow? It's a fun thought, right? But the truth is, a rainbow isn't a physical object at all. You can see it vividly. It looks like it's right there, but you can never reach out and grab it. It's literally one of nature's most beautiful optical illusions, and once you understand exactly why that is, it's going to completely change how you look at the sky. To get there, our lesson plan today covers 5 quick topics: the great sky illusion, refraction explained, internal reflection, the geometry of the arc, and finally, the double rainbow phenomenon. Let's get right into it.
Part 1. The Great Sky Illusion.
Let's set the scene. Picture that moment right after a heavy rainstorm. The air feels super clear, but lingering way up there are millions upon millions of tiny water droplets. Think of these droplets as a giant, invisible canvas. Now, the main character here is the sunlight itself. At first glance, sunlight just looks perfectly white to us, right? But in reality, that white light is hiding the entire visible spectrum. It's actually made up of all these different colors blended seamlessly together.
Which brings us to step 1 of our lesson, refraction explained.
Let's zoom in super close on just a single droplet of water. We want to observe the very first interaction between that white light and the rain. When a beam of sunlight enters a raindrop, something amazing happens. We call it refraction. See, water is denser than air, so the light actually has to slow down as it crosses that boundary. And this sudden change in speed causes the light to bend. It's a crucial vocabulary word for today, and it's the absolute critical first step in making a rainbow.
But here's the really cool part about that bending process. Each hidden color packed inside that white light bends by a slightly different amount. It's like a traffic jam where everyone takes a slightly different detour. Red light bends the least, while violet light bends the most. Because they're bending at completely different angles, the white sunlight is literally split apart into its individual colors. And boom, that is where we get the classic spectrum we know so well: red, orange, yellow, green, blue, indigo, and violet.
Moving right along to step 2, internal reflection.
Now, let's follow that newly separated colored light as it travels deeper inside our little raindrop, all the way to the back wall. This is where internal reflection kicks in. When the light hits the back of the water drop, it doesn't just pass straight through and out the other side. Instead, the inside surface at the back of the drop acts almost exactly like a mirror. The light bounces off that curved inside surface and heads right back toward the front of the raindrop.
So let's summarize this incredible journey through the drop. Step 1. The light enters and bends. That's our refraction. Step 2, the light bounces off the back wall. That's internal reflection. And step 3, as the light exits the front of the raindrop, it bends again. This second refraction makes the colors spread out even more. And because of the very specific angle it leaves at, a single individual raindrop ends up firing only one specific color directly toward your eye.
Now think about that for a second. If one droplet only blasts a tiny ray of red to your eye, and another droplet only sends green, and another sends blue, well, a single drop isn't a rainbow. It takes literally billions of raindrops working together. Billions, perfectly orchestrated across the sky to paint that massive, magnificent spectrum that you're looking at.
This leads perfectly into Part 4, the geometry of the arc.
Now that we understand the micro level of a single drop, let's zoom way out to answer a big picture question. Why on earth is a rainbow curved like an arc? Well, the answer lies in geometry, specifically the magic number of 42 degrees. For a ray of red light to travel from a raindrop in the sky and perfectly hit your eye, it has to come in at exactly a 42-degree angle. Compare that to violet light, which reaches your eye at a slightly tighter angle of exactly 40 degrees. So you have all these continuous angles bouncing from the water droplets back to your eye. And geometrically speaking, all those points of light form a giant circle around the exact spot in the sky that's directly opposite the sun. Wait, if they form a giant circle, why do we only ever see an arc? Well, the horizon is literally blocking the lower half of the circle. Rainbows are actually full, complete circles of light. But from our vantage point down on the ground, the Earth just gets in the way. However, if you're ever lucky enough to be a passenger in an airplane flying high above a storm, you can sometimes look down and actually see the entire glorious circular rainbow. How cool is that?
All right, time for part 5, the double rainbow phenomenon.
Consider this our advanced bonus lesson for the day. Let's decode the physics behind one of nature's rarest and most amazing sights. As we just learned, a standard primary rainbow happens with a single reflection inside the drop. That gives us bright colors with red on top. But every so often, the light actually reflects twice inside the raindrop before leaving. That second bounce creates a double rainbow. Because the light is bouncing that extra time, it loses a little bit of energy, making the second rainbow look dimmer. And amazingly, that second bounce perfectly reverses the color order. So the double rainbow has red on the bottom, on the inside, and violet on the outside. It's totally magical to see, but completely explained by physics.
Which brings us right back to our very first question, why you can never actually reach a rainbow. You know the feeling, if you try to walk toward one, it always seems to just back away from you. That's because a rainbow isn't located in one specific physical place. Its existence strictly depends on the exact geometric alignment of the sun, those millions of floating raindrops, and your eyes. If you move, the specific raindrops sending light to you change. You are literally seeing a brand new rainbow from your new position.
And that leads perfectly to our final, most provocative thought of this lesson. Does anyone ever see the exact same rainbow as you? The answer is a resounding no. Because moving even just 1 inch changes your geometric alignment with the sun and the rain, the person standing right next to you is receiving light from an entirely different set of water droplets. It's pure, cold, hard science, yet it means that every single time you look up at the sky, you are experiencing your own entirely unique rainbow. So next time you see one, I hope you remember those billions of droplets working just for you. Thanks for joining me for this explainer, and keep exploring the amazing physics all around us.